So, distinguish the difference between correlation and causation. This is 200 words.
Correlation doesn't necessarily imply causation, but causation always implies correlation. You could have two variables that are strongly positively or negatively correlated with each other, but it's not a case necessarily of one variable causing the other or vice versa. You could have a third variable that causes both of them. For example, if you compared zip codes and you looked at the number of sidewalk cracks and the number of fire hydrants in a particular zip code, they may be positively correlated, but what's really causing them both to increase would be higher population in that zip code.
Okay. And so, right. So in that case, there would be no causation, but there would be correlation, right?
I have a question.
Yes.
The causation is the correlation, but the correlation is in the linear relationship, right? The causation it can be the non-linear shift. Just like if you eat hamburger and your utility will be first is increase when you eat more hamburger. When you are hungry, when you have enough, and then you have eat more hamburger, your utility will
Go back to your original statement.
correlation.
Go back to your original statement.
Sorry. I mean, you just said the correlation guarantee the correlation, right? Correlation doesn't imply the correlation, right? But the correlation may be non-linear relationship, but the correlation is the linear relationship, right?
I don't think it has to be a linear relationship. Correlation, you're saying, has to be a linear relationship?
Yeah. We talk about correlation coefficient is linear model.
Right.
Yeah.
There would still be a correlation if it was a non-linear relationship, wouldn't it?
Because you can prove in the statistical method. For example, I take you eat hamburger and the utility. It's not a linear relationship. But if you calculate the correlation in linear model, it's not so good as before. Maybe it's real. There's no correlation between the eating hamburger and the utility of this causation. It's not linear.
Take two things that are related exponentially.
Yeah.
Take two things that are related exponentially, like one minus the square of the other.
Right.
Then overlay a small increment. If a line might approximate it properly, and you can estimate the fit of that line, but on a different increment, it would be a totally different fit.
So if it's the correlation, you're saying, it presumes that it's a linear relationship, it might fit it to be practically nearly zero, at least statistically, significantly close to zero. If it's a non-linear relationship, I guess.
That's a question I pitch online and I read some books. That's a question whether the correlation must be in the linear relationship.
I think that the correlation would still exist, it's just may not be statistically significant. But it would still be there, it would still fit as either being positive, inverse, and happiness, or whatever it would think for you. Well, maybe what you're saying is that it would fit it so improperly and drive it towards insignificance. Does that make any sense? So, let me draw it and see if I understand your question. So, what you're saying is that if you want to figure out utility and hamburgers, the relationship would probably look something like this, right?
So goes down, then you get to 1 point.
Now, marginal utility might tend to drop, but the utility would increase. Right? Marginal utility would drop, but overall utility would always increase. You would presume under any normal utility. So if this is the case, even at an extreme, what's the correlation? Well, if you're saying we're fitting one line and look like that, since the residuals are so far away, you're saying, well, maybe this drives it to be insignificant, right? Is that what you're saying?
Yeah, maybe the correlation was 4. Maybe it will be 0 in mathematics when you calculate the result.
Just saying the correlation doesn't describe the relationship.
that are non-linear related.
Like you can have correlation statistics, but it's meaningless.
Right.
It's not really descriptive. A correlation district, by definition, describes a linear relationship. So if the relationship is not linear, then the correlation is meaningless.
Right, I would agree with that, I would agree with that. That it might be meaningless, it might drive it towards insignificance.
But there are techniques you can also, like you could regress, not maybe in this case, but you could regress against the log of your variable or the end. So,
Or marginal utility.
Yeah, or-
Where we have,
we can transform your dependence variable in some way that makes it closer to linear, if that's the only tool you have.
what you can transfer, right, yeah. Or you can, toss in another variable if it, gosh, what was the one example? The nonlinear relationships that look like this, I think you take the natural log, the other ones you add, tack on another one. We're talking about correlations. Anything like that. Yeah, I would agree with that statement. But I would say that correlation would still be there. But I don't know.
What if it, like, to be able to fit like an x squared function that was perfectly, it was a mirror, on either side, and so if it fit to something like that and you didn't transform it, then you wouldn't see a correlation. It would be identically zero if it's got an infinite number of data points.
Yeah. Yeah.
So then you get something like that, and it wouldn't work, but if you took the
Right.
square of those numbers and also you have a perfect linear relationship, then you're okay with that.
I would agree with that, I think. Yeah, that's a good point. So if it's causing a relationship that's so random and so haphazard that you can't fit a straight line on it, I could certainly see that.